Assalamu alaikum everyone. Today's video is on two exam questions on bounds. Let's get started. So here's the first question. You've got a right angle triangle. Okay, that's your right angle, 90-degree angle. And the side opposite is your hypotenuse. Looks like it's got something to do with Pythagoras theorem, but let's just quickly read the question. A is 8.3 centimeters, correct to the nearest millimeter. Okay. B is 6.1 centimeters, correct to the nearest millimeter. Okay, so the degree of accuracy is to the nearest millimeter. Now, to get from 10 millimeters, make 1 centimeter. So the degree of accuracy in this case is going to be the nearest millimeter, which is 1 millimeter is equal to 0.1 centimeter. Okay, so we're gonna do a degree of accuracy to 0.1, and based on that we're going to find the upper bound for C. Okay, so this question does relate to Pythagoras theorem. So whilst using Pythagoras theorem, I like labeling my sides as side 1 and side 2. Specifically, I don't like using a squared plus b squared equals c squared, just for this reason: what if they switch the letters around? So I always call the two sides that make the right angle side 1 and side 2, and then I start off my formula like such: s1 squared, so side 1 squared, plus side 2 squared is equal to hypotenuse squared. And now I'm going to substitute the letters in. Okay, so side 1 was c, so c squared, side 2 was b squared, and h hypotenuse is a squared. To find c squared, I have to subtract b squared both sides. So I've got c squared is equal to a squared minus b squared. Okay, now I've got the expression. I'm going to look at the potential bounds for A. So for A, it's upper bound because the degree of accuracy is 0.1 centimeters or 1 millimeter. I'm going to halve that degree of accuracy, 0.1 divided by 2 to 0.05. So to find the upper bound of A, I'm going to take the value of A, which is 8.3, and add 0.05 to it, which gives me 8.35. And then the lower bound of A, find it. I'm going to take 8.3 and subtract 0.05. So I always take the degree of accuracy, half it, and then add and subtract, find the upper and lower bound of the individual component. That's A, done. Now we're gonna try B. Same thing for B. The upper bound is going to be 6.1 plus 0.05. 6.15. And the lower bound for B will be 6.1 minus 0.05, 6.05. Okay, now I have to work out the upper bound for C. In this expression, I'm subtracting. So for subtraction and division, the upper bound will be the largest possible value of C in this case, and that is attained when we subtract from the upper bound of A the lower bound of B. That's going to give us the largest possible value. So the upper bound of A is 8.35, so I'm going to do 8.35 squared minus the lower bound of B, which is down here, 6.05 square whole squared. That'll give me the upper bound of c squared. So to get c, essentially I'm going to have to square root this answer as well. So let me just do that now. I could have written that earlier, but even now it's fine. So that'll give me the upper bound of c, which is going to be as follows. So I can use a calculator for this. It's a calculator question. So 0.35 squared, that's the square root of 9.7225 minus 6.05 squared, which will be 36.6025. And then if I square root the answer, I get 5.754997828. That is the upper bound of C. Now we're going to try the next question. So a high-speed train travels a distance of 487 kilometers in 3 hours. The distance is measured to the nearest kilometer. Okay, so the degree of accuracy is 1 kilometer. Okay, so for the distance, the degree of accuracy is 1 kilometer. I'm going to divide it by 2, half it, so that gives me 0.5, and I add and subtract. So distance upper bound will be 487 plus 0.5, which gives you 487.5 kilometers. And distance lower bound will be 487 minus 0.5, which is 486.5 kilometers. So I got the distance upper bound and we got the distance lower bound going. The time is measured to the nearest minute. We'll put the time here. I'm going to convert the 3 hours into minutes. So that's going to be 3 times 60, which is 180 minutes. Okay. So the time upper bound, we know that the time is measured correct to the nearest minute. So the degree of accuracy is 1 minute. I'm going to divide that by 2, which is 0.5 minutes. Okay, now the question says by considering bounds, work out the average speed in kilometers per minute. So I don't need to convert the minutes back into hours. Okay, so the time upper bound, it's going to save me some time, is going to be 180 plus 0.5, which is 180.5 minutes. And the time lower bound is going to be 180 minus 0.5, sorry, which is 179.5 minutes. Okay, now when it says by considering bounds, I have to find the upper bound and lower bound of speed. Now speed is distance divided by time. So the upper bound of speed is the largest possible value of the speed. To get that, because there's division involved, I'm going to divide the upper bound of distance by the lower bound of time. And then to get the lower bound of speed, that's the smallest possible value for the speed, I'm going to divide the lower bound of the distance by the upper bound of time. Okay, let's substitute these values in. So distance upper bound is 487.5 kilometers. Okay, and time lower bound is 179.5 minutes, not kilometers. Okay, and they want the speed in kilometers per minute, not kilometers per hour. So I don't need to make any conversions now. So let me type this in my calculator. Let's see what I get. Get a really long number. I get 2.715877437 kilometers per minute. Okay, let's find the lower bound. So the distance lower bound is 486.5 kilometers divided by the time upper bound, which is 180.5 minutes. That gives me also a long number, 2.695 290,859 kilometers per minute. Okay, so I have to now see to what degree of accuracy are these two numbers the same. So if I were to round these two numbers to two significant figures, so the second significant figure would be this digit here and this digit here. Both of them would be 2.7. If I go to three significant figures, on the left I'd get 2.72, on the right I'd get 2.70, so it wouldn't be the same. So I write this sentence, this speed can be rounded to 2.7 kilometers per minute to two significant figures. Okay, and that's it. That's my answer. Thank you for watching. Bounds are very likely to come up in the calculator exam this year. So please watch the video and hope this helps with your exam.